what you're going to do on a normal problem when you do one of these. Okay? When you take and look at iron, in this case iron and water, you have two different amounts. You're going to have to do both processes in which to figure out which one's limiting. So what we're doing is we're dividing and conquering. The left side of the room is going to do iron. You're going to take the 67 grams and go figure out how many grams of Fe3O4 is made. And then the right side of the class is going to take the 36 grams of water and do a mass-to-mass on that. So everybody in here are different points. If you got a 10 out of 10 on this assignment, or in this little quiz, the bottom one was the mass-to-mass. Some of you are missteps. You got some missteps going on in there, and we need to get that ironed out. So I'll come around as you have questions on doing your problem. Okay, your problem. So if I have the 36 grams and it runs out, it'll make so much product. And if I have 67 grams and it runs out, I'll end up with so much product. They're not going to be the same amounts. Okay? If they are the same amounts, neither one is limiting. So if I come up with the same answer, the right side of the room, use the water, and they come up with the same answer as the left side of the room, which is iron, neither one is limiting. It's a perfect number of ingredients to make it go. And we're not normally going to have that. So, finish up what you're doing. Most of you are probably done, or really close to being done, at least with your setup for your particular one. You have to do both of them when you determine limiting, okay? So it's like you just do two problems for one question. All right. Don't look at what I have circled and that type of thing. Look at your problem. Did you come up with the right amount? If you used iron, did you come up with 92.6? Okay, so left side should be divided by 55.85 to get the moles. Grams cancel out. Moles to moles of iron cancels out. Then moles of Fe3O4 to moles of Fe3O4 cancel out. And there's 231.55 grams. So there's several things that can go wrong along the way when these problems are worked out. Students like to multiply this by 3. And so they would have like 167 point whatever. Not good. Some people will put 3 up here and say there's 55.85 grams for every 3 moles of iron. That's not good. Because everywhere you see grams to moles, it's 1. The only time we're using numbers other than 1 mole is in our ratio. Our second reaction we use goes from grams of water to grams of iron, Fe3O4. We have two amounts. They're different. The one that is lower came from what we call limiting. So the iron makes less amount than the water. If it makes less amount than the water, it ran out. And when it ran out, it only made 92.6. It's impossible. You ever hear that? I want to give it, athletes, you give me 110%. Sorry, iron can only give 100% of 6.7. Once it's done, it's out, it's not going to make any more. Okay, it's impossible. It can't make any more than 92.6. Now water, if it ran out, it would make 116. It can't run out because iron runs out first. Okay? So iron's limiting and water's in excess. Excess means there's some left over. Okay? So when we look at the question has question A, which is limiting. Some students will say Fe3O4 is limiting. What's wrong with that? That's a product, right? Limiting has to be what? It has to be a reactant. It has to be something that ran out. So the answer would be iron for A. For B, the answer, what's the mass of iron-free oxide? Well, it'd be the one with the least amount. Okay? Be the one with the lesser amount. Any questions? So you just got to do 2 setups. All right? The third one is the most difficult one for students to get right on a test. I would say a little over half get it right on a test. Okay? And it's just I guess a tough thought process in which to figure out. This is pretty much straightforward. We just go ahead and find out 2 products, and the one with the least amount is our answer. That's pretty easy to figure out. But when it comes to ask how much is remaining of the excess, that one's a little tougher. So guess what we're going to do? To find out how much of the 36 grams actually reacts, we're going to take the limiting. We're going to take the 67 grams. And we're going to determine how much of the 36 is actually used up. It's going to be less, right? Because it's got to be less because the 67 grams, when it runs out, it'll tell us how much water is going to be used up. So that's what I want you to do on the last setup. I want you to do a setup that takes your limiting, your grams of iron, and then goes to grams of water. So you got all the information in these 2 setups. All right? If you want to write both setups down, like it's up here, first, do that. Because if you look back over your notes, you only have 1 setup, and then you're like, well, how did I figure that out? So write the other setup out, okay, that you didn't do. So left side you want to do water, right side you want to do iron. And then the last thing you'll do is you'll do a third setup and you'll go from iron to water. Okay? So I'm going to give you some time to do that, and then I'll come around. You guys got questions? So, question. The question on page 314 at the top, letter C, it says, what mass in grams of excess reactant remains when the reaction is completed? So it really wants to know how much remains left over. Okay? Now, some students will get to this point and they'll get this answer and they'll say, there's 28.8 grams that remain left over. Okay? That's wrong thinking. Okay? That's the answer, but that's the wrong thinking for the final answer. Okay? So even if you get to this step, you come up with 28.8 grams. The question's asking you, how many grams of water remains unreacted? And some people will say, well, 28.8 grams. No. What is the 28.8 grams? What does that represent? That represents how much reacted. So if 36 grams is available and you use 28.8 grams, what's left over is the difference, right? So that's how I came up with 7.2 grams. You have to subtract the 2. So, oh, how much is left over? Oh, around 7 grams is left over. We've got 7 grams that didn't even do anything because the iron ran out. Okay? So if I want more iron to react, or more water to react, I got to have more iron. Okay? So this is a setup. This is the answer. How much is used up? The 28.8 grams of water is how much used up. And then you take and subtract the 2, and that tells you how much remains unreacted. Okay? So what I will ask you to do is 2 problems for tomorrow to put in your notes. We've got a good 20 minutes to do this. This is longer than other classes had. So you could probably get it pretty much done before you go. And then we can talk about it tomorrow. So this is called a limited reactant. Remember, first thing you do on a limited reactant always is you have to determine between the 2 reactants which one is going to make the smaller amount. So you do two separate calculations. If you want to find the one in excess, you have to do that step first so you can find which one limits the reaction. Once you figure out which one limits the reaction, then you can take that reactant, which is iron, and then figure out how much of the other one is going to be left remaining. Okay? All right. So the questions would like you to do is on page 892, and they're problems 201 and 207. Page 892, problems 201 and 207. Okay? Now, 201, problem 201, it does not ask you to determine the limited reactant, or determine how much of the excess remains unreacted. It only asks you to determine the limited reactant and how much product is made. Okay, that's 201. 207 will have two parts. One will be for you to determine the amount of I2 formed and then how much is in excess. Okay, that's what it's going to ask you to do. Okay.